In the last lecture of partial differential equation, we study the what is the partial differential equation. So an equation containing partial derivative coefficient, then the equation is called partial differential equation. And we saw how to obtain what is the formation of partial differential equation by eliminating arbitrary constant. Okay, and we take example of the formation of partial differential equation by eliminating arbitrary constants. Okay, so in this lecture, so we study here obtain the partial differential equation by eliminating arbitrary function. So what is the method here? So that is the elimination of arbitrary functions and obtain the partial differential equation. Okay, so then let u is a function of xyz. U is equal to u of xyz and v is a function of xyz. Be two functions, independent functions of variable x, y and z. And we treat z as a dependent variable and x and y are the independent variable. Z is a dependent variable and x and y independent variable. Okay. Also we write here let f of u is equal to 0. What is u? U is a function of xyz. U is a function of xyz. What is v? V is a function of xyz. Then we take f of u is equal to 0. Be an arbitrary function. Be an arbitrary function between u and v. So f of uv be an arbitrary function of u and v. Okay. So we eliminate that arbitrary function and obtain the partial differential equation here. Okay. So this is equation number 1. This is equation number 1. So differentiate partially this equation 1 with respect to x and y. X and y we get. So differentiate this equation. So what is the derivative of this? U is a function of x, y, z. V is a function of x, y and z here. Okay. So now we differentiate this equation with respect to x first. So what is the derivative of this? Dou f by dou u into derivative of u, dou u by dou x. Okay, dou u by dou x. But in u, z is a function of x and y. We taking here derivative with respect to x, keeping y constant. Okay, then dou u by dou z, because z is a dependent variable. We taking a derivative with respect to x, keeping y constant. Here, so what is this? Derivative is dou f by dou u. Then dou u by dou x. U is a function of x, y, z. Dou u by dou x plus dou z by dou x. Dou u by dou z. Dou u by dou z into derivative of z. Dou z by dou x. Okay? Plus v is there. Okay, again dou f by dou v, differentiate with respect to x, dou f by dou v, then dou v by dou x, dou v by dou x, but in v z is there, y is a constant, z is there, then dou v by dou z, dou v by dou z into derivative of z with respect to x, dou z by dou x is equal to 0. So we differentiate this partially with respect to x, where u and v are there. Okay. So we put dou z by dou x is equal to p and dou z by dou x is equal to q notations. So we get this equation, that is equation number 2 here. So very simple equation here. Dou f by dou u into dou u by dou x plus dou u by dou z into p and so on. So this is equation number 2. Now we again differentiate partially this equation with respect to y. Okay, so then dou f by dou u directly. So similarly dou f by dou u, partial derivative of this with respect to y. So that is dou f by dou u. But u is a function of x, y, z. So with respect to y, keeping x constant. So that is dou u by dou y. Okay, then what is the derivative of u? Derivative of u with respect to z, dou u by dou z into derivative of z with respect to y, dou z by dou y, that is q. That is q. Plus dou f by dou v but v is a function of x, y, z. Then partial derivative of this with respect to y, dou v by dou y plus dou v by dou z into dou z by dou y. So that is q. So this is equation number 3 here. So we eliminate from equation 2 and 3 dou f by dou u and dou f by dou v. We eliminate from equation 2 and 3. We eliminate dou f by dou u and dou f by dou v from equation 2 and 3 we obtain here. Okay, so taking determinant, so that is we eliminate multiplying something and solve this equation, simultaneous equation. So automatically we eliminate this. Okay, so we can write in determinant form. This is here, this coefficient is here, this is here, this is here, and this is here. So this is the determinant is equal to 0. Okay, this determinant is equal to 0 here. So solving this determinant, so second order determinant, this into this, so this into this, minus this into this, so this into this is equal to 0 here. Okay, 0. So now solving this equation, so what is the coefficient of p? After multiplication of this, after simplification of this equation, we write this into p plus this into q is equal to right hand side this term here. After simplification, simplification is very simple here. Not necessary to given this simplification here. Okay, so this equation can be done like that. This equation. Okay, but what is this? This is the determinant. This is the determinant here. Okay, this is the determinant. Then what is this? So that is dou u by dou y into dou v by dou z. This dou v by dou z minus dou v by dou y. So this can be written as this determinant into q plus this can be written as this determinant. Okay. So then what happen here? So this is what? So this is the Jacobian here. Jacobian. So this equation can be written as so this equation can be written as, so this is dou of uv by dou of yz into p. Okay, plus dou of, so this is notation, just this is a notation of this is this. So that is a Jacobian of uv with respect to yz. So this can be written as like that, dou of uv by dou of yz plus p into dou of uv xz q plus what happen is equal to dou of uv by dou of xy. So this is okay. So this is this equal to this. So this is Jacobian. Simply Jacobian of uv with respect to xy, uv with respect to yz, uv with respect to xz, uv with respect to xy. So we write this is as a p, big P. So this is small p. So this is a dou z by dou x plus this is what? This is q. This is small q and this is r. This is r. So this is. So put something lambda y. This is equal to lambda y. This is equal to lambda something and putting these values in this equation, we get this equation. So this is where p, q, r are the functions of x, y, z, and this equation, this partial differential equation, we eliminate arbitrary function. And obtain the differential equation. Partial differential equation is called Lagrange's equation. So this is the Lagrange's linear differential equation. This equation is called Lagrange's equation. So we take an example. So take example and obtain the partial differential equation by eliminating arbitrary functions. Okay, arbitrary functions. Let us take an example. So eliminate the arbitrary function eliminate the arbitrary function f from f of x plus y plus z, x square plus y square minus z square is equal to 0. So eliminate the arbitrary function f from this and obtain the partial differential equation solution. Let u is equal to what? X plus y plus z. And what is v? V is equal to x square plus y square minus z square. Okay. Therefore, putting the value of u and v in this equation, so the given equation becomes here. The given equation becomes f of, so this is u, f of uv is equal to 0 here. F of uv is equal to 0. So this is equation number something 1. Okay. So differentiate this partially. Differentiate partially with respect to x and y. We get. So differentiate this equation with respect to x and y, we get. So that is, what is the derivative of this? So dou f by dou u into dou u by dou x plus dou f by dou v into dou v by dou x is equal to 0. So this is equation number 2 here. And dou f by dou v into dou v by dou x, dou f by dou u, dou u into dou u by dou y, with respect to y, plus dou f by dou v into dou v by dou y is equal to 0. Equation number 3. So differentiate this equation with respect to u, with respect to x partially, and with respect to y, we get these two equations here. Okay, and so differentiate this with with respect to x and y. So that is dou f by dou u and derivative of u with respect to x. So dou f by dou v and derivative of v with respect to x. So that is dou v by dou x and so on. So eliminating dou f by dou u and dou f by dou v from equations 2 and 3, we get what? So that is eliminating this. So that is what here? So dou u by dou x. So we write this in determinant form, solving this differential equation. I think you solve simultaneous equations and eliminate this. This is a very simple method. We write directly in determinant form as it is. So that is the dou u by dou x, dou v by. So we eliminate this and this. So dou v by dou x, dou u by dou y, and dou v by dou y is equal to 0. By eliminating dou f by dou u and dou f by dou e from those two equations, we get this here. Okay. So what is the dou u by dou x? So this implies that what is the dou u by dou x? Partial derivative of u with respect to x. keeping y constant, keeping y. So what is the derivative of this with respect to x? So that is derivative of x is 1. Derivative of y is 0. Keeping y constant. Plus, what is the derivative of z? Z is not a constant. Z is a dependent variable. Z is a function of x and y. So what is the derivative of z with respect to x? Dou z by dou x. So that is p. 1 plus p. 1 plus p. What is the dou v by dou x? Dou v by dou x. Partial derivative of v with respect to x. Keeping y constant. That is a dependent variable. Temporarily constant. So what is the derivative of this? Dou v by dou x. Derivative of x square is twice x. Y keeping constant. So derivative 0 minus 2z into derivative of z. So dou z by dou x. So that is p. P. What is the dou u by dou y? Again, partial derivative of u with respect to y, keeping x constant. So derivative of x is 0, y derivative 1. Plus, what is the derivative of z? Dou z by dou y. So that is q. 1 plus q. Then again, what is the dou v by dou y? Dou v by dou y, derivative of keeping dou v by dou y. Partial derivative of this with respect to y, keeping x constant. So derivative of this is 0. So derivative of this is 2y. Minus what is derivative of z square? So minus 2z into derivative of z with respect to y, dou z by dou y. So that is q is equal to 0. Okay. So we solve this equation. So that is 1 plus p 2y minus 2z q minus 1 plus q into 2x minus 2z p is equal to 0. Okay. So this is the partial differential equation. Okay. This is the partial differential equation. So we simplify this. So you simplify this equation. So we get what happened? So this is y plus z into p minus x plus z into q is equal to x minus y. After simplification we get this. So this is the partial differential equation of this function. After eliminating this arbitrary function, we get the partial differential equation. So this is the example here. So we take another example. Eliminate the arbitrary function f. Example 2 from f from z is equal to f of xy upon z. So that is the function given here. Okay. So let solution. Let z is equal to f of xy upon z. Let z is equal to f of xy upon z. So this is given here. Equation 1. So we eliminate this arbitrary function and obtain the partial differential equation here. So differentiate equation 1 partially with respect to x and y, we get. So what is the partial derivative of z? Partial derivative of z with respect to x, keeping y constant. So what is the derivative of z? So that is the dou z by dou x. So what is this? This is the p is equal to. Derivative of this is this. What is the derivative of this? With respect to x, keeping y constant. Here z is a dependent variable and x and y are independent variables. So what is the derivative of this? This is f dash x upon xy upon z into derivative of this is f dash of this into derivative of this. So what is this? So that is z square. Okay, z square. Then what happened? With respect to x. So then, what is the derivative? Derivative of xy with respect to x. Derivative of x is 1, y as it is, and z as it is. Y is 8. Minus. What happened here? xy as it is into derivative of z with respect to x. So dou z by dou x. So that is p here. That is p. Okay. Again we differentiate this equation with respect to y. So that is dou z by dou y. So derivative of z with respect to y, dou z by dou y. So we denote this by letter q, small q, is equal to, what is the derivative of this? So that is f dash xy upon z into derivative of this f dash into its derivative. So that is division rule, z square. Then what is this? Derivative of this xy with respect to y, keeping x constant. So derivative of y is 1. So x, z as it is, minus xy as it is. What is the derivative of z with respect to y? Dou z by dou x, that is q. Okay. So we get these two equations here. So this equation is say 2 and this is 3 here. So from equation 2 and 3, from equations 2 and 3, so what happened here? So f dash xy upon z, f dash xy upon z, 1 upon z square here. We take this is here and 1 upon z square is equal to what? P divided by this factor, 1 upon z square here, f dash xy upon z, and p divided by this. So this is yz minus xy p. Similarly, f dash xy upon z, so 1 upon z square here. So this is q upon this. So that is q upon xz minus xy into q. Okay. Therefore, left hand side is same. Therefore, right hand side. So this equal to this. So that is p upon yz minus xy p is equal to q upon xz minus xy q. So after simplification, on simplification, we get, so xy, so this can be written as xy xp minus yq is equal to 0. Means multiplying this p into this and q into this and adding those terms, we get this equation. So xp minus yq is equal to 0. So this is the partial differential equation of this equation by eliminating arbitrary function. Okay. So this is a very simple method for obtaining the partial differential equation of the given function by eliminating arbitrary function. Okay, thank you.